Okay, this one we're finding the points of discontinuity or provide intervals where the function is continuous. I think I'm going to follow the second option. Okay, if the point of discontinuity or removable state so. Okay, this is a polynomial, so it's not discontinuous. So this is continuous for negative infinity to positive infinity. Nothing surprising there. Okay, alright. We're looking for points of discontinuity. Now, this one has two things going for it. We have a fraction, which means we can't have zeros in the denominator, and we have a radical. It's a square root, so that means we can't have negative numbers in there. Alright, so first off, we can just find the zeros of the denominator. That would be x squared minus 4 equals 0. That's going to give us x equals plus or minus 2. Okay, so we can't have plus or minus 2, so that's going to be a point of discontinuity, and then there's more. All right, we can't have a negative inside the radical, so that means we have to solve this inequality. When is x squared minus 4 less than 0 or greater than 0, whatever you want to solve for? Okay, if I solve for this would be exclusion in the domain. If I solve the other version, that will be parts of the domain. We'll get the details later. Alright, so we're going to solve this inequality, and I want to know when it's negative. One way to do this is to factor it. So I got x minus 2, x plus 2, and what this does is gives us values on a number line. That one's going to give us negative 2, and we've got a positive 2. And let's put some numbers in here. Alright, but the ones we're interested in, or the ones that we need to focus on, are negative 2 and positive 2. These stand as boundaries of where this inequality equals 0, right? Or this expression equals 0. So what happens is, if you pick a number in this interval and it's positive, then the whole region is positive. Okay, and that's true for any of the other two regions. So we have three regions where they're going to be like negative, positive, negative, or positive, negative, positive. Something like, or it could be all positive or all negative. Either way. Alright, here we go. So just picking a number, plug in negative 4 into this expression. Alright, let's put it in this one. Might be easier. Negative 4 is 16, minus 4 is 12, so it's positive. So this region to the left of negative 2 is going to be positive. Plug in 0, that's going to give me negative 4. Alright, and plug in positive 4 has the same effect as negative 4. 16 minus 4 is 12, so it got positive. So it went positive, negative, positive. So the part that makes this true is this region, right? Where x is between negative 2 and positive 2. So we just solve this inequality by using this number line. Alright, so what does that mean? The question was, what are the intervals of continuity? So this thing is discontinuous here, right? Because the negative, this region, this interval, gives us negative values in the radical. So this is an exclusion. So I guess I should have solved the other way. Alright, so what is our answer? To answer the question of where is this function continuous, it's going to be negative infinity, negative 2. So we're excluding this region. And from 2 to positive infinity. So that's the intervals of continuity for number 9. That was kind of long for that inequality. Let's see if we have time to do another one. Sure. This one's a little easier, I think. Number 10. Okay, again, we're going to factor this. X times x plus 2. And what is that one? X plus 3 and x plus 2. Okay, what's the difference between this one and last one? Well, one, we don't have a radical. The only thing we have to deal with is the denominator. Also, we have x plus 2, which cancels. So in the graph, what this looks like is a hole in the graph. Okay. By the way, if you look at it in a calculator, the hole won't even register. Okay. So x plus 2 is a point of discontinuity, but it is a removable discontinuity. Right. So x equals negative 2, that is. But x equals negative 3 is just it's not a hole. It's a vertical asymptote. All right. So what do we got? We have x equals negative 3 is not in a domain, and x equals negative 2 is not in a domain. Okay, so let's see. That means we're going to go from negative infinity to negative 3, and negative 3 to negative 2, and from negative 2 to positive infinity. Okay, and we have a removable discontinuity at x equals -2. And if you want to get technical about it, and a non-removable discontinuity at x equals -3. Now, in the directions, it really said to only really point out if it's a removable discontinuity. We don't have to point out the non-removable discontinuities. But that just kind of addresses that. All right, that's enough for that video.